So we have two trigonometric functions here. One is a cosine function and the other is a sine function. Now the basic sine and cosine function, so let's look at y equals sine of x or y equals cosine of x. Both are continuous functions. They're periodic functions. This is what the two functions look like, and it just keeps going on and on following the pattern. It's periodic. So these are continuous functions. So if cosine and sine are continuous, if we are trying to find the continuity of this function cosine of 2x, the only thing we need to worry about is the continuity of the function 2x. So f of x equals 2x is a polynomial function. It's continuous everywhere. So if 2x is continuous everywhere, then cosine of 2x is also continuous everywhere. It's again a periodic function. So then the function is continuous at every real number. So it's continuous in the interval negative infinity to positive infinity. Now, if we look at the next function, which is sine of 3x cubed minus x plus 1, since sine is a continuous function, the sine function is continuous, we need to just look at the inner function, which is the function 3x cubed minus x plus 1. Again, that's a polynomial function which is continuous everywhere. So therefore, we have the continuity of this function is from negative infinity to positive infinity. Let's look at another function, f of x equals sine of the quantity 2x over x plus 2. So 2x over x plus 2 is the inner function. So let's call that g of x. So g of x is equal to 2x over x plus 2. So we've discussed this earlier. The sine and cosine functions are both continuous in the entire interval negative infinity to positive infinity. That is for every real number. Now, since the sine function is continuous, we only have to worry about the continuity of the function 2x over x plus 2. So the function 2x over x plus 2 is continuous everywhere except when the denominator x plus 2 is equal to 0. The denominator x plus 2 is 0 when x equals negative 2. Subtract 2 on both sides. So this function is continuous everywhere except at negative 2. So negative infinity to 2, open interval. We just discard the negative 2, which delete the negative 2, and then continue from there on, negative 2 to infinity. So the only point that we have deleted on the real number line is negative 2. So it's everything except there's that one exception of negative 2. All real numbers except negative 2. Now let's look at the tangent of x function. Remember that tangent of x is equal to sine of x over cosine of x. So tangent of x is defined everywhere except when cosine of x is equal to 0. So when the denominator is 0, that's when tangent of x is not defined. So we need we need to make sure that cosine of x is not equal to 0. Let's see where it is equal to 0. So cosine of 0 is 1, remember that. Cosine of pi over 2 is equal to 0. Cosine of 3 pi over 2 is equal to 0. cosine of 5 pi over 2 is equal to 0, and so on. And the same thing with the negative angles. Negative pi over 2 is the same as cosine of pi over 2, etc. They're all equal to 0. So if cosine of 3 pi over 2 is equal to 0, we can be sure that cosine of negative 3 pi over 2 is also equal to 0. So cosine of x equals 0 when x is equal to plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. So the function y equals tangent of x is continuous at all real numbers except plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, every odd multiple of pi over 2, plus or minus. That's what we've included as exceptions, all real numbers except. Now suppose we have y equals tangent, let's say 2x, then we have to make sure that cosine of 2x, which is the denominator, so that's sine of 2x over cosine of 2x, we need to make sure of the fact that cosine of 2x is not equal to 0. So let's see when it is equal to 0. 2x would have to be equal to plus or minus pi over 2. Remember, that's our 2x. We need to make sure that angle 2x is not equal to plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc. All odd multiples of pi over 2. So we need to make sure that the angle 2x is not equal to these numbers. So solving for x, we can divide both sides by 2. So we have x is equal to plus or minus, I'm dividing by 2, so that becomes a pi over 4. Dividing by 2, that becomes a pi over 3 pi over 4. Dividing by 2, each number I'm dividing by 2. 5 pi over 4, and so on. So the discontinuities are at, so it's continuous at all reals except, and the discontinuities are at plus or minus pi over 4, plus or minus 3 pi over 4, plus or minus 5 pi over 4, and so on. So these are the points at which the function is discontinuous, and we're talking about the function tangent 2x. Instead of x, we have 2x, and that's how we had to divide by 4, and these numbers would be the exceptions.